this, the natural log of 1/5. So you can enter here, find the interval which the function is increasing. It's increasing from this number to infinity. So you will put parentheses. Where are my help? Where are my parentheses? I just use regular parentheses like this. Okay, okay, got it. I got it. Okay, so we will be from natural log 0.2. Oh, the parentheses already pop up for natural log. Okay, so 0.2. Oh, they want enter your answer. Okay, it doesn't say. Okay, divided by outside, divided by 6. Where's my division symbol? Okay, here. Divided by 6. And then comma, infinity. Okay, find the interval of which function discretely. Okay, so then I will have to enter the other one. From negative infinity to this number. But you cannot enter negative 0.27. It will not accept it because it doesn't say anything about rounding. So be careful how you enter it. Is this good enough so far before we move on?
I'm checking it right now.
Okay. I don't know if you had 5. Did you have 5? Because if you didn't have 5, then you have a different answer. Did you have e to 5x?
No, I had e to 7x.
Ah, so don't enter this answer then.
Okay.
So you will have to enter, you had 7x, and then 7, 8. So you will enter the same thing. So let me just, do you want me to work on your problem with the 7?
Either way.
Okay, so I'll continue my problem, but let me just show you the one with, so if you have f of x e to, you said 7x, correct?
Right.
Minus e to negative x. Is this correct?
Yep.
Okay, so then your f prime will be 7e to 7x plus, oh no, this was plus initially. Right? You had plus, not minus.
Right.
Okay, perfect. Okay, minus e to the x to negative x. And when you set this equal to 0, you will have 7e to 8x minus 1 over e to the x equals 0. So then you will have 7e to 8x equals 1, or e to 8x equals 1 over 7. So then your 8x will be natural log of 1 over 7. So you have to enter everything the same in the sense that you will have natural log of 1 over 7 divided by 8 to infinity. Don't forget parentheses. So it's increasing on natural log 1 over 7, everything over 8, comma, infinity. But you have to use parentheses. Be careful how you write this in. Maybe you can write a fraction line or divide, or I'm not sure. So this is increasing, and it's decreasing on the other side from negative infinity to natural log of 1 over 7 over 8.
I see. Yes, it's correct.
So then this will give us a minimum. There is no maximum. You will write none or something. I don't know how you write nothing. But this will be a absolute and local minimum. But we have to find it. And the way you find it, you have to plug it in the function. What am I plugging in? I'm plugging this in the function. So for your function, which page am I on? 17. For your function, which was e to 7x plus e to negative x, we have to plug in natural log of 1 over 7 divided by 8. E to 7 Oh no, 1 over 7 divided by 8 plus e to negative natural log of 1 over 7 divided by 8. Okay, so in order to write the exact answer for this, um, 7/8, so it's e to natural log of 1 over 7 raised to 7 over 8. That's interesting, very interesting. Plus e to natural log of 1 over 7 to negative 1 over 8. And this will be, this is torture. This is absolute torture. So I use the property that says that e to natural log of this is just x. E to natural log of this is just x. So you have to enter it like this. Gee whiz. 1 over 7 to negative 1 over 8 is 1 over 7 plus 1. Look at that. Okay, so once I don't enter it just yet. And once I factor this, 7 over 8 minus that is 7, so 7 plus 1, so it's 8 over 7. Wow. 8 over 7 times 1/7 to negative 1 over 8. Or 8, 1 over 7, just enter it like that. So it's 8 over 7, parentheses, 1 over 7 to negative 1 over 8.
Okay.
So the property that I use, I'm going to write it on the side. E to natural log x is x. So all this needed to be done only because they are not allowing any, they're not allowing any approximations. So don't enter this one. So I have, it's in the denominator. I have to change it to, oh, I can. Yeah, I can change it. Yeah. So I'll change it to, okay. This is, so this is 7 to 1 over 8. So this is 8 times 7 to 1 over 8 minus 1. Or 8 times 7 to negative 7 over 8. Oh my goodness. Wow. I'll have to tell the coordinator about this problem. Thank you for bringing this to my attention. Okay, did you enter any of these answers?
Yeah, so for the local minimum value, it did take 8 over 7 times 1 over 7.
So you entered that.
Yeah.
Okay, it has to accept it. Okay, let's see what else. Oh yeah. After all this, so there is no maximum, there is only local minimum. Now also find the inflection. Wow. Okay, where is my first derivative? How many pages ago? Okay, this was my first derivative.
I do want to mention that, like, when I was doing it for all of them, I tried to type in do not exist, and when I did that, the inflection point came up as do not exist, and then the last part of it came up as do not exist.
Okay, so you want to skip that? I don't know. I haven't looked at it.
Yeah. So
it's possible that both quantities are positive, so that's why. Let me just write the second derivative. So it's 49 e to 7x plus e to negative x. So yes, this is always positive. It's never 0. Got it. You're right. So no inflection points. And the function is concave upward all the time because it's always positive. So the function will always be concave upward. So you will write from negative infinity to infinity. for that concave upward. Is that okay?
Yep. Thank you.
Thank you. Wow. Wow. Okay, good. At least, sorry, I just gave up on my problem that I had, so I continued with this one because I wanted to help Zacharias finish that up. Sorry about that, but it's the same calculation. Good. Good. Excellent. Okay, anything else? Anything else? Is there another topic or you need help with something else?
Will we have any linearization or approximation
Yes,
questions?
yes, in here, yes. Would you like to choose one?
I'm more so just putting my notes together and looking at like what I want to bring in as a cheat sheet, the equations for those two things.
Do you want me to give an example of approximations using differentials?
Sure.
You want to pick a function or?
Yeah, let me flip back to that. That's 3, you said, right?
So we can approximate, for example, 1 over the square root of 99. So you immediately have to write that this is the same thing with f of x plus f prime of x dx. I will immediately write that. And now I have to identify the function. I have to find its derivative. I have to find x, and I have to find dx. So, can anyone give us f of x?
Is it 1 over square root of x?
Excellent. Can anyone give us f prime? So this is a little bit, difficult, but you have to be careful. You just have to change it like this first. So when you differentiate, be careful now, we are not integrating. So we're bringing negative 1/2, x to negative 1/2 minus 1, which is negative 3/2, or negative 1/2 over 2 the square root of x cubed. What is x in our problem and what is dx?
X is 100 and dx is -1.
Excellent. So we have everything. Now I can write the equal symbol because what I'm going to write, it equals this. So f of x, when I plug in 100 here, I have 1 over 10. Then dx is negative. I have to put a negative, but I also have a negative derivative. So it's positive. 1 over 2, 10 to the third. I meant 100, of course. 100 to the third. So then I have 1 over 10 plus 1 over the square root of 100 is 10 3 times. So the least common denominator is 2,000. And here I have 200. So 201. And this is it. Of course, it has to be kept in a fraction form. But of course I will check my answer. It has to be very close. If it's not very close, I'll say, oops, I must have done something. So 201 divided by 2,000 and 1 divided by 99 raised to power 0.5. When I click enter, I have to get something very close to this. Very nice. You should always check, of course. Errors may occur.
Professor,
Yes,
so for the final answer for this, we should keep it as a fraction.
yes, it
and
has to be
not
a fraction.
entirely simplified?
No. You cannot simplify
Okay.
201 over 2000. It has no common factors.
Well, yeah, but like not like the actual decimal.
In a decimal, no.
For
You
the
should
fraction.
look in the calculator and make sure that you are very, very close. Of course, if dx is bigger, then the error may be a little bit bigger, but you should be very, very close, and you should keep it as a fraction form. But no decimals over
Right,
fraction, you know, so if I have 2.01, I will multiply by 100. No decimals in a fraction. Good. Anything else? Anything else?
I don't think we can do a related rates question before the end of class, could we?
I don't know. We can try. We can start it.
Okay.
Do I need WebAssign? Or
I'm looking at the problems real quick just to find a good
sure.
or one that makes sense.
If not, we'll stop in I don't know, 8 minutes, and we'll continue it tomorrow. Same. It's okay to start.
Okay, I think it's 3.7 is related rates. And we can go to problem 15.
Okay, so you said in 3.7. No, you mean 3.9?
I went to 3.7, but we can go to 3.9.
No, no, no.
I think that's the
Yeah, that's fine. So let's look at 3.15, and we can do 3.9 tomorrow. But I don't have a 15 on this 3.7.
Oh, this isn't WebAssign. I'm sorry. This is out of the book.
Oh, sorry. Okay.
Did we skip 3.7, the natural sciences one?
I think
Am
we
I-
skipped 3.8, not 3.7.
Okay.
Find the average rate of change of the area of a circle with respect to the radius. Okay. Area of a circle, so this is area equals pi r squared. Is this the one?
Yes.
Okay. And we have from 2 to 3, from 2 to 2.5, and 2 to 2.1. Okay. Average rate of change of the area with respect to the radius, if r changes from 2 to 3. Okay. So the average rate of change will be f of x f of x2 minus f of x1 divided by x2 minus x1. So you see, this is the fixed one. This is what changes. So the fixed one will be this. So when r is 2, so I have 4 pi. So here I have pi r squared minus 4 pi over r minus 2. Pi r squared, so f of x2 minus and f of x2 are just r pi r squared. And because this is the fixed one, I plug in 2, so I have 4 pi divided by 2. This is what I am going to enter in the calculator. I'm not going to do what some of you like to do, repeat the same thing 10 times. No, I cannot. It's okay. I'm not saying that the method is wrong. No, the method you're choosing or using is perfect, but I will not use it. So I have pi x squared minus pi x minus 4 pi, sorry. Okay, no, I don't want that. So pi x squared minus 4 pi, close, and divide by pi x minus 2. X minus 2. And then I go to second and table, and I punch in 2.1. I punch in 2.5, and I punch in 3. And I go, I don't know how many decimal digits they want. I didn't look. I'm going to copy 3, or maybe 2. What do they want?
They didn't say anything.
Okay, fine, then I will decide on my own. Okay, so the first, for this one is 12.881. The next one, 14.1372. And for the next one is 15.70796. Okay, then find the instantaneous rate of change when r is 2. Okay, so when r is 2, I'm going to put 2.000001. And I got 12.566. So instantaneous 12.56637. Who cares? I know what A prime is 2 pi r, and all I want to plug in is 2. So 2, so it's 4 times pi. 12.56637. That's the best approximation. I don't have to do anything else. It's this one. Because now we know how to check. We didn't know when we started that. And the last one here. Show that the rate of change of the area of a circle with respect to... I will not have enough time in 1 minute to finish this one. So we're going to leave part C for tomorrow. So the 15th. Because it will take me to read it and explain what it is, and so we'll look at the answer tomorrow.